Derivatives and rates of change, Part 3. Recall that the tangent line to the curve y is equal to f of x at the point P, a f of a, is the line through P with slope m is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. You could also use this definition, where the limit as x approaches a of f of x minus f of a over x of a is m, but this definition is preferred by most people. It's a lot easier to simplify. We want to find the equation of the tangent line to the curve at the given point. So for finding the equation of the tangent line, that means we will probably use point slope form. So we have y minus y1 is equal to m times the quantity x minus x1. So we need to find our point x1, y1, and then find our slope, which will be equal to the derivative of our function at whatever our input is for our point. So the first thing we'll need to do is find that point. So we want to find x1, y1, and we're given that we're looking for this at x is equal to 3, which means we want to find f of 3. So we'll substitute 3 into our function, so into the square root of 2x plus 3, so we have the square root of 2 times 3 plus 3. So this is equal to the square root of 6 plus 3, which is the square root of 9, which is equal to 3. So far we have y minus y1, which is this 3, is equal to m times x minus x1, which is this 3. And now we just have to find that slope. So we'll have to use our limit definition of a derivative. So now we want to find the slope of this tangent line. So we have m is equal to f prime of x, which will be equal to the limit as h approaches 0 of f of x plus h. So we'll substitute x plus h in for our x's. So that'll give us the square root of 2 times x plus h plus 3 minus f of x, so that's just our square root of 2x plus 3, all over h. And you might remember that when we have two terms in our numerator, especially if they are involving any sort of square roots, then a good simplification strategy is to multiply by the conjugate. Recall that the conjugate of a minus b is a plus b. So it's the same things, except instead of subtracting, we're going to be adding the two terms. So we'll multiply the numerator by 2x plus h, the square root of 2 times x plus h plus 3. And we'll still have this square root of 2x plus 3. But now, instead of subtracting, we're going to add. So before we were subtracting, and now we're adding these two terms. And you just want to be careful that you also multiply the denominator by the same thing. That way we're effectively multiplying by a fancy 1. When you multiply by the conjugate, you've created a difference of squares. So rather than distributing all of this out, we're going to use our wonderful shortcut, where a minus b times a plus b is equal to a squared minus b squared. So you square the first term and you square the second term. So this is equal to the limit as h approaches 0 of this guy squared. And when you square a square root, you remove the square root because those are inverse operations. So we have 2 times x plus h. And I'm going to distribute this. So that's 2x plus 2h plus 3 minus this guy squared. And again, squaring a square root removes the square root. So we have 2x plus 3 all over. Don't forget to distribute this guy to your h. It is frequently lost. So we have h times the quantity, the square root of 2x plus 2h plus 3 plus the square root of 2x plus 3. And now we can do a bit of simplification. 2x minus 2x subtracts out, and 3 minus 3 subtracts out. And we're left with the limit as h approaches 0 of 2h all over h times the square root of 2x plus 2h plus 3 plus, I don't have much room, the square root of 2x plus 3. Now we have a common factor between the numerator and denominator, so the common factor of h will divide out. And this is equal to the limit as h approaches 0 of 2 over the square root of 2x plus 2h plus 3 plus the square root of 2x plus 3. And now we shouldn't end up with a 0 over 0 anymore, so we can use direct substitution. So we have 2 over the square root of 2x, because this is as h approaches 0. X is not approaching anything at the moment. So we end up with 2x plus 0 plus 3 plus the square root of 2x plus 3. So that's 2 square roots of 2x plus 3. So we have 2 over 2 root 2x, sorry, the square, wait, no, yeah, 2 root 2x plus 3. There's so many 2's here. And luckily, some 2's will divide out. So we're left with just 1 over the square root of 2x plus 3. So we found that f prime of x is equal to 1 over the square root of 2x plus 3. And this gives us the slope at any point x. And the trouble is we don't want just any point or any input. We're specifically interested at where x is equal to 3. So this means we need to find f prime of 3. So we'll substitute 3 in for x. So we have 1 over the square root of 2 times 3 plus 3, which is equal to 1 over the square root of 6 plus 3, which is 9. So that's 1/3, which means that the equation of the tangent line to our curve is y minus 3 is equal to 1/3 times x minus 3. And that's the equation line to this curve at this point.